Hello, in this video, we are very pleased to present our ECCV paper, Controllable Contextualized Image Captioning, Directing the Visual Narrative Through User-Defined Highlights. Traditional image captioning has been extensively studied as a major computer vision task. However, image captioning is more about examining the model's ability to recognize objects in the image and phrase them into open vocabulary language. We don't see a lot of use cases for models to caption just a single image. More often, images in real life come with contextual information, making captions more meaningful and illustrative. This prevalent use case, as seen in settings like Wikipedia and news captioning, is formulated as a task called Contextualized Image Captioning, where text-based context crucially enhances the relevance and depth of image captions. However, the contextualized caption can become ambiguous when the context is growing long. An image can have multiple plausible contextualized captions by focusing on different aspects of the context. To further assist writers in this circumstance, we propose Controllable Contextualized Image Captioning, Ctrl-CIC. The users can select different highlights from the context for which they want the contextualized captions to be focused on. As you can see in this image, we might have different captions for the aloe image by focusing on the shape or water storage of the plant. Formally, in Ctrl-CIC, we want to produce caption T for image I based on context C with specific focus on highlight H. Ideally, such Ctrl-CIC model should be trained with highlights inputs in addition to context image pairs and label captions. Without such existing dataset, we have to derive the pseudo-highlights for training based on context, image, and captions. While generative methods with modern LLMs might get us high-quality pseudo-highlights, they possess substantial costs for training on large-scale datasets. Instead, we design a computational method to derive the highlights, where we compute the similarity of the aggregated caption embedding with each context token embedding. The resulting relevance score, SI, for each context token can be considered the probability of token I being in the highlights. Now we have the training data, we will introduce two types of controllers that can be used for controlled caption generation. Firstly, there's the prompting-based controller. During training, we select words with high relevance scores and prefix them to the label captions. The model will spontaneously learn to condition its output based on the prefix. During inference, we can construct similar prefix prompts based on user-selected highlights for controlled generation. We also propose an alternative approach, the recalibration-based controller. During training, we calibrate the encoded embedding by multiplying token-wise embedding with normalized relevance scores so that the model can focus more on the highlighted tokens and adapt to the varying embedding distribution. We also train a relevance score predictor to simulate the normalized weights for the inference stage, during which we perform similar calibration, but additionally amplify the weights at highlighted positions by certain values to emphasize the highlight. For evaluation, we need actual highlights realistic enough to evaluate the performance of the model, so we instruct GPT-4 to select highlights candidates and combine them to construct the Ctrl-CIC testing set. To evaluate the quality of generated Ctrl-CIC captions, we adopt and design reference-free objective metrics for evaluation from different perspectives. Moreover, we design a GPT-4V empowered evaluator that assesses the quality of generated Ctrl-CIC captions relative to traditional CIC captions by calculating the final score through division. The evaluator comprehensively marks both captions across 4 aspects. Finally, the evaluation results indicate that the proposed controllers not only achieve considerable success in control tasks, but also surpass fine-tuned baseline models and zero-shot VLMs in performance. While they may not match the performance levels of GPT-4, they offer superior efficiency and a more compact model size. Here is a demo showcasing the capabilities of the recalibration-based controller at Ctrl-CIC. Without specified highlights, it generates traditional CIC captions that cover the entire context. More importantly, the model excels at producing controllable captions that flexibly focus on different parts of the context when given various highlight inputs. By changing the input image, we observe that the model not only incorporates the highlighted context, but also connects the visual components of the image with these highlights. More details on this work can be found on our project page.